And essentially, the goal is to talk about in a case where we're given capacitors in parallel like this, and we want to combine it into an equivalent circuit as shown here to the right. All right. And we're first going to say that IS, or I source, is equals to I1 plus I2 plus I3. And that's simply from the idea that a current entering a node has to equal all the currents leaving that same node, right? Okay, so using our knowledge of current through a capacitor, again, please watch my previous videos on capacitors to understand where these equations are coming from. But we know that I1 can be written as C1, the change in voltage or change in Vs over dt, plus C2, again, the change in Vs over dt, plus C3 Vs over dt. I'm going to go ahead and I'm going to pull out a dVs over dt. And I'm going to be left with C1 plus C2 plus C3. This dVs over dt. And we're left with C equivalent is equals to C1 plus C2 plus C3. Say here a general equation for capacitors in parallel is simply C equivalent is equals to C1 plus C2 plus dot 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 plus Cn. Or you can say that this is I is equals to 1 to n. The sum of I equals to 1 to n, Ci. And that's your equation.